speaker, Dr. Zoheir Ezziane from the Higher Colleges of Technology here in the UAE, is going to be talking to us about trends in analytics. Dr. Zoheir Ezziane received his BS in computer science from USTHB in Algeria, his MS in computer science from UCF, and his PhD in engineering from FAU. He has developed two operational software packages using AI. He supervised projects funded by the NSF in the US and the University of Pennsylvania. He's a former research fellow at Harvard, Oxford, ICL, Stanford, and Yale. Currently, Dr. Zoheir is managing the Learning Resources Center at HCT and conducting research in multidisciplinary fields, including learning analytics and machine learning. So without further ado, please welcome Dr. Zoheir Ezziane.
Thank you so much. Thank you so much. Well, many years that I've been teaching, I taught students from different countries, and I just noticed something very simple. The students are always students, and teachers are also teachers. As a teacher, as a faculty, we prepare so much teaching material. We prepare notes, exercises, samples, solutions, and we put them on our folders to be accessed by students. And when we go and teach, some students go and look through those slides, through those notes, and some don't. So basically, I've been going through this and said, what is the best approach to allow students to look at what the instructors are preparing and spending time? And it has been very challenging to find the right recipe that would help students really focus on what is important and how they improve their learning and how they get engaged in the classrooms. This is exactly what I have been trying to reach. So with my experience in research in artificial intelligence for many years, I've been trying to find a way, to find an approach based on AI to see how it's possible to really help students learn more and engage more. So this is what I would like to focus on, even though half of the part of these contents will be less technical, but the other half will be a little bit more technical. It talks about algorithms and AI. Even though it's a research topic, the slides will be a little bit maybe boring a little bit, a lot of text, but please bear with me. I will try to make it as interesting as possible with more talking and with less pictures, but I will try to be as informative as possible with this approach. So basically, the whole idea of universities, teaching, learning, academic performance, I just noticed that at the end of the day, the whole point is that educational institutions are being called to answer very challenging questions related to what students are learning and whether the costs are justifiable. Countries, institutions spend a lot of money on this, and we want to know, are those costs really justifiable, and are the students learning? So basically, we have nowadays, we have large data sets available about digital footprints of students. We have academic performances in student grades, in grade reports. All of those are available. We have retention rates, sometimes low, sometimes high. We have also learning experiences of students. We have enrollment as well as employability. All of those data sets that are available to us, what we want is we want to improve the student cycle, student life cycle. The moment that student comes in, spend some time at the university, exit, and find a job. And at the end, institutions will be able to reach their academic goals. So what is important is we all agree, at least as instructors or as faculty, that collaborative learning is a paradigm where instructors or tutors and students, when they get together in peers or in groups, it really helps students to learn. I have managed a tutor system at HCT, and I noticed that when students work together in peers, it's amazing how much they learn. When students help each other, they feel more comfortable asking their fellow students than sometimes asking teachers. So the grades, the academic performance of those students, when they go and sit together, improve dramatically. And I have looked at grade reports of students who were at risk, who were experiencing problems. it's amazing to see how those students who are at risk improve their academic performances. So I noticed that students can feel very comfortable talking to their fellow students. So I have reserved rooms, study rooms for those students, and I put an agenda, put a calendar where students can come and pick the time they have a chance to sit with the tutor, and it's amazing how this approach works. So at Cornell University, at the Teaching Excellence Center, they have reported that conducting effective collaborative activities could lead to better self-esteem, higher order thinking, and leadership skills. So it's amazing to see how students, when they go through this, how they improve their self-esteem, they become more self-confident, as well as improve their academic performance. So, data science. Now, this is a very big buzzword nowadays, especially with the explosion of data that is being available. DS, finally, what it does, it processes big data. It generates patterns and provides decision makers with useful information using data analytics as well as machine learning. That's basically a summary of data science. So how can we use data science in teaching and learning, since that's the topic of this symposium? Well, I believe that data science in teaching and learning can track learners' activities and experiences, store them digitally, somewhere in the digital space. Big data sets are accessed also from various sources, including learning management systems, from student information systems, social media, web tools, and many other available sources. And it should provide, in this case, information on student learning experience and performance, as well as it should help to improve curriculum design, instructional design, and advise students on how they can improve their learning as well as performance. So in this case, then, what is learning analytics? I believe that this learning analytics field, it is basically investigating and processing all of the digital footprints that students leave behind whenever they access those LMS, MOOCs, as well as educational video games. They leave those traces, they leave those footprints, and we, people who are interested in this field, should go and analyze wherever those digital footprints are and see how we can extract patterns that could be as useful as possible to advise our students. So what we need is basically in this learning analytics, we need to increase the awareness of both students and instructors and allow them to make constructive decisions on how to make things more effectively. Also, we need to analyze the learning experience and then recommend personalized plans, if possible. That's very challenging, by the way, for performance improvements. And we try to optimize the learning process. Optimize the learning process. See how students can spend time on something that is more relevant. So optimizing the learning process is also one of the challenging topics in learning analytics. So basically, LA, learning analytics, it has 4 different views on how to achieve those goals. 4 angles. The first one is very simple. It's descriptive. The second one is diagnostic. The third one is predictive and prescriptive. The first one is very simple because this tool is available in all learning management systems. It just describes the situation. How many students are in my class, how many students are failing, how many students are doing well, etc. Very simple, that you can find and access from any tool that is available nowadays. Now, diagnostic is why students are failing, why they are not getting good grades, how come they are not accessing my digital space, how come they are not going into my lectures that I put online. That's also using sometimes artificial intelligence can help, or even less. Predictive is what will happen to my next exam, how many students will pass, how many students will fail, how many students will get A's, B's, C's. I'm trying to predict what's going to happen. Okay, so this is also available through AI. Now, prescriptive is some sort of personalized plan. How can I prescribe? How can I write a recipe How can I prepare something for my students to improve their learning? So basically, it is a personalized plan that usually it's face-to-face between an instructor and a student to see and to design a plan, and probably this plan will help students individually to improve their academic performance. This is some sort of a plan or a chart of a learning analytics to see how really the picture should be framed. So basically, we have all of those resources at the bottom: learning management system, student information systems, grade books, web tools, wherever the digital footprints are. So all this data is there, big data, large data sets that sometimes can have different formats. We need to do some data capture. We capture all of this data, and then we need to pre-process, clean it, put it in a certain format, in tables, in simple data structures that will be helpful for future artificial intelligence tools, for machine learning algorithms, to be able to look at what are those data sets are and see how those patterns can be extracted. When those patterns are extracted and put in different data sets, now is how it's possible to analyze and interpret those data sets, and how the students will be able to access their learning paths and see what they are doing wrong or how they can improve their learning experiences. And it will also help instructors to see how they can advise students better. And it will also help administrators and academic managers to see how the curriculum should change a little bit to reflect how students are learning, and how to possibly provide new courses, provide better advising, change a little bit the curriculum. All of those decisions are made at the top after all this data has been processed properly, cleaned properly, and provide the instructors, students, and administrators with better information and useful information and meaningful information. Because nowadays we have so many reports on BBLearn, on other platforms. We have so much out there, and we don't know where to look at in order to make things better for the students. So we need to find a good, effective approach that can tell us and give us what we basically need to make a positive change. Now, there are so many LA platforms out there, and so many universities, east, west, around the globe, are using those tools and platforms. And just to mention a few examples that I was able to get my eyes on, the SNAP, which has been used at many universities, including University of Wollongong. It analyzes student interactions in online discussion forums. So it goes to this discussion forums and see how students are giving their feedback on particular course, particular area. Review is another tool used also, for example, at the University of Technology in Sydney. It's a criteria-based assessment tool to monitor student learning. And the Connect for Success, used also at many universities, including University of Windsor. It is an incoming first-year student monitoring program. So what it is, it looks at the first-year students and see what can we do with those students who are facing issues with learning, and they will sit with a specialized team and provide them with certain guidance in order to improve their academic performance. And usually first-year students we're having a lot of issues with, because they finish high school, they come to university, the environment is different, they don't know sometimes how to deal with university rules, policies, and courses, and they sometimes, some of them, they find themselves, they lag behind. So that first-year tool helps students at that level to be put on the right track. What happened? There you go. Back, sorry. Let's see, did I miss anything? No. Now, to do the learning analytic tool, there are constraints and challenges, where it's very important to let the students, the faculty know that we are designing a tool that monitors students' performance, that monitors certain classes for the benefit of helping students. We don't want to know why teachers is doing this or that. That's not the objective of this tool. The objective is to help students and faculty. So we have to let the students as well as faculty know that we are gathering this data for the purpose of improving learning. So those ethical issues and privacy issues, they have to be dealt with before you go ahead and start collecting data and processing it. And also we are depending too much on digital footprints, because there is another topic called multimodal analytics, where we take into consideration in a very controlled lab how students are looking at the faculty, whether they are sleeping, or whether they are really focusing, or whether they are fully engaged, or whether they are taking notes. Those are multimodal formats that are not covered in this lecture. But in learning analytics, purely and simply put, they rely way too much on digital footprints. And also how much resources should be invested on students who are at high risk. What kind of resources will the university or any academic institution spend in order to improve those high-risk students to improve their academic standards? How much resources? Will we just provide tutors? Will we give them additional time with the faculty? This has to be also resolved. And the last one is whether or not the student will seriously commit and follow recommendations to improve his or her academic standards. Because with all these studies, if we do all of this, and at the end of the day, students really don't follow those steps, okay, that's really a waste of time. So we have to find a mechanism that will allow students to really follow those guidelines that were done for them in order to improve their academic achievements. Okay. Now, the role of artificial intelligence. Now, it has been used in many fields, including teaching and learning. Now, what I want AI to do here, basically an adaptive learning and teaching, is an educational method that uses AI to provide personalized learning. We all know this. This is not new. We need to develop intelligent models in order to predict performance, improve teaching, improve learning. It's also part of the game. We need to use AI to optimize the learning paths. That's the challenging thing. How can AI optimize the learning paths and give the students only what they need to improve their skills? And what we need is to extract those meaningful patterns from big data. Now, we have so much data out there, and sometimes terabytes of data. In order to find what is useful, you are really going to need a very effective AI tool that will dig and find those patterns. So that's now the goal of my lecture, is to reach this level, collaborative filtering, the CF method. This method is part of AI, and it's also part of what we call a recommender system or recommendation systems. It recommends basically to people, to users, what is interesting, what has been useful for their learning experiences. Basically, we use this maybe on a daily basis. When I would like to watch a movie, and I'm in the mall, and I have so many movies out there, and I'm don't know which one I'm going to watch. I like some of them based on the title, but I'm not sure which one is more interesting. I go to Google, I put the name of the movie, and then I find so many people giving certain rating. I'm like, okay, a lot of people gave 5 stars or 6 stars to this movie. I think it's interesting. So a lot of people use that thinking at least, if they're not sure, to pick a certain choice. And this is happening all the time. You go to Amazon, you go to Facebook, all of those social media networks are using mostly the same method, the same approach. Okay, so this is what I would like to apply on learning analytics, to see how students would recommend certain topics, certain contents, certain slides, certain PDF files for their fellow students to improve their grades. Okay, that's the approach of what I'm going to be discussing in this lecture. So basically, we want to estimate the preferences of users by determining the embedded correlation between revealed responses of users. I would like to analyze the preferences of the learners, of the students. And there are so many examples, as I mentioned, in e-commerce, in movie recommendation, and social networks. So that's the idea of this approach. Okay. CF, collaborative filtering for learning analytics. What we want to do is, I want LA, learning analytics, to be considered as a recommendation system. I want the CF to recommend particular topics, particular tools, particular contents to students who need help. Okay, so I want the CF methods to use the set of preferences by users to predict other items. And here there are two categories of CF. There's what we call memory-based and what we call model-based. I'm going to start with the first one, memory-based. The memory-based is basically has been implemented in many commercial applications, such as Amazon, Barnes and Nobles. And here there are also two approaches in memory-based, what we call user-based and item-based. What's the difference between them? I'm getting a little bit technical here, but I'm going to try to simplify this. User-based simply is that, for example, we have a number of people who like, for example, the book called Python. Okay? Myself and two more like Python. But I liked another book called The Use of AI in Learning Analytics. They are the other people in my group who like Python are not aware of. So the system will say, listen, guys, there is a book called AI in Learning Analytics that someone liked in the same preference group. So that new book will be recommended to the other people who are not aware of this new book. That's the idea of the user-based. In the item-based, we put items in the same group or similar items. For example, we put 3 or 4 books that are similar, and when we say similar, it means they have been recommended by a number of readers. And then we look at people who have some similarities with those users, and we tell them, listen, guys, there are a certain number of books that have been recommended that you're not aware of. And we show them this list. So the approach is different, whether it's user-based or item-based. And here I am basically putting some differences between the two. And at the end of the day, both methods will look for similar items, whether it's user-based or item-based. Similar here means what is the distance between the two items or the two users. How can I say that these two users are similar? How can I say that these two items are similar? Well, here we use metrics. We calculate the distance between items or between users, and based on this value, we can tell if two items or two users are similar. And here's an example of similarity metrics. There are so many of them. Pearson, cosine, there are so many. The one that I found very useful and common is called the Pearson correlation. It's just a formula that looks at the rating of a learner for a certain item, and where you see the bar is the average of all ratings. Okay? And this formula helps to find the distance between two users or two items. The second formula that is used is called rating prediction. It helps to predict rating. Why do I need to do that? Well, very simple. Because there are some users who did not have a chance to rate a particular item, but they have rated other items. So how can I predict, to some extent, the rating for that item by that learner or by that user? There is a formula also, okay, there are so many of them, that is used to help the system to predict certain rating that was not given yet. And then I came up with an algorithm. So people who like algorithms might like this slide. People who don't like algorithms might find it extremely boring. I'm really sorry about this. But in the field of computing, we cannot live without algorithms. Algorithms are everywhere. So before implementing, I need to write an algorithm, set of steps that are needed to solve a problem. That's basically what an algorithm is. So here, I put this algorithm. I give some inputs to my algorithm, and I need some processing. And at the end of the day, I want this. I want to notify or recommend to the learner a list of contents, list of files, list of URLs that will be useful to make the story successful. So this is the goal of my algorithm. And in the middle, there is some processing where I look at the similar items, I look at the ratings, and I pick the highest rated items, and I will send that to my learner. And hopefully, my learner will be happy. What are the limitations of this memory-based? Well, first of all, those similarities are based on common items, and hence they become unreliable when there are missing values. When there are so many missing values and very few that are known, it becomes a little bit challenging because we do a lot of predictions, a lot of filling the gaps that will make this approach a little bit challenging and less reliable. To overcome this shortcoming, we rely on machine learning more. I use AI more than I use it in memory-based. So what we call the model-based, that use machine learning to do more of predictions. And here we have so many models. We have what we call Bayesian belief nets, clustering CF models, and the famous neural nets, the deep learning, the power horse of artificial intelligence. So in model-based, the ML, as usual, find complex patterns based on training data and then make predictions. And here we have so many approaches. We have what we call matrix factorization. We have clustering based, and we have neural nets. In classification algorithms, from the name, classification comes from classifying, creating categories. What we're going to do here, we're going to use CF models if the learner ratings are categorical. Categorical means everything it has a category, not numbers. Regression models, where statisticians love this field, and singular value decomposition models can be used for numerical rating. So if we have numerical ratings, I use regression and singular value decomposition. If I have categorical, I use mostly classification algorithm. MF, I'm going to show you a figure. Finally, figure is coming to see how this matrix factorization works. Please bear with me just with this slide before the figure shows. 3 minutes. My goodness, I have to skip this then. Okay, let's look at how this MF works. I have the matrix, my contents or books that the learners like, and I have the learners. They put some ratings, and there are some empty spots. What I want is to decompose this into two matrices, okay, called the learner latent factors, what is hidden for the learners, and what's hidden for the contents. And what I need is those missing, for example, for the content. For example, it could be how technically oriented is the content, or how engaging is the content, or how easy are the examples, or how recent this content is. Okay, so there will be rating for each and every of those slots. And for the learner, for example, we can ask how much do you like the content, or how much do you like recent contents, or how technically strong are you, or how knowledgeable are you about this content. And then we go to the neural nets, deep learning. How can I use neural nets to learn? Well, since I don't have much time about this, I'm going to go straight to the figure. So if you remember the previous slide, that figure, it has some empty spaces, something that is unknown. or the learner did not rate yet. And here what I want is I have some students or learners. I have some contents that they were able to read, and what their features are. Remember the features, whether the content is challenging, is engaging, is recent. All of those are here. Some of them are empty. And then what I want is I want to predict this, the rating for this particular learner. Neural nets will do the job. Neural nets will try to find that rating through learning. Ooh, the matrix approach. Okay, there we go. The conclusion. Sorry, I skipped so many details, but thank you.